Okay, everyone, welcome back to our statistics class. We're on page 53 of our statistics class notes in section 4.2. We were talking about the correlation coefficient in studying regression analysis. So I'm going to return to our example of miles versus the fuel consumption. Now, I didn't actually show you the scatter plot, so before you read all this, let's look at the scatter plot here. Okay, so these were the results. This is exactly what I had cut and pasted into your notes. And remember, we got this by going from stat, regression, simple linear. I chose X to be miles driven, and I chose Y to be fuel consumption. We could switch them around. The correlation coefficient would stay the same. Scatter plot would look different. But let me cancel this because I already did it. Okay, now notice that I didn't show you the scatter plot last time. If you actually want to see the scatter plot, what we do is we come over here and we click on this right arrow at the bottom. It's the second page. Up here it says 1 of 2. We'll go to a second page, and here's where the scatter plot is. Okay, so you can see the scatter plot. You can see how StatCrunch fit the best line through those points so that the vertical variation, the distance vertically from any point to the line, is minimized. The sum of all those distances, which is a mathematical thing you don't need to know about. It's just that the vertical variation is minimized. Okay, so going back to the notes, in this example, I added a new vehicle. So I added a new vehicle, and I wanted to describe and interpret the association. Notice what the scatter plot looks a lot different. These were the points I had before, but I added a new data point out here at about 800 miles and 3 gallons. So let me go back and add that point so you can see it here. So I'm going to add 800 here at 800 miles, and it only took 3 gallons. Pretty amazing car, huh? Okay, so I'm going to come back, edit, and I'm going to just go ahead and run it again. All right, so there's my results. Look at everything changed here. Correlation coefficients, whoa, it's a horrible correlation now. Why is that? Let's look at the scatter plot. Correlation coefficient went all the way down really close to 0. So I actually have the wrong line drawn in by hand. This StatCrunch put the better line. Notice what happens is the line kind of left this location and got bent down towards here because it's trying to minimize the sum of all these vertical changes. That's why the correlation is so horrible now, because of this value here. So when you go back to the notes, I actually drew this in by hand before I looked at that. So that's what it was before. Now when I add this outlier, what happened is it came way down here and it had a horrible correlation coefficient. So what do you think happened with the one point that does not follow the trend? Does it seem accurate? This guy is an outlier. It's not even anywhere near the straight line that these guys were close to. As the number of miles driven increases, fuel consumption also tends to increase. Okay, that's what we're talking about here. But if the potential outlier in this graph is corrected or removed, what do you think will happen to the R value? R gets back closer to 1 because it was about 0.91 when I was up here, and now it was 0.05 back here. So the line looked more like this, didn't look like it went through anything good at all. Likely though, if we think about this data point, it's a bad recording of data. How could it only take 3 gallons to drive 800 miles? That's not likely true. So we probably would be okay with just deleting that point because somebody probably recorded it wrong. Maybe it was supposed to be 80 miles. It took them 3 gallons. Okay, example 64. Actually, this one's from your textbook because I thought it was a good comparison. Predicting land value. Both scatter plots concern the assessed value of land with homes on the land, and both depict the same observations. So this scatter plot here compares the number of rooms in a home with the value of their land. And this scatter plot here compares the acreage that somebody owns, how many acres their land is versus the value of the land. Hopefully you agree that this one is a much stronger correlation. There is probably a correlation here, but it's not really good. It's pretty weak. What is the value of the land for the one with 18 homes? If I were going to read this, here's the guy that 18 homes. I kind of came up, drew it across. It's around $70,000. What is the approximate value of the land for the homes? There are approximately 5 acres of land. So 5 acres of land is, right, if something was on 5 acres of land, it would hit the line that fits through it the best. There's actually no data point there, so I'm going to use the line that fits through this the best as a prediction of it. So that would be about $120,000. Are there associations positive? Are these associations positive or negative, or is there no trend? So they're both a positive uphill, right? Positive association or correlation or relationship. All of those words mean the same thing, and you'll see them at different times in the homework. Which do you think has a stronger relationship with the value of the land? The number of acres of land or the number of rooms in the home? Well, we said, just kind of glancing at the scatter plot, this is a pretty weak correlation or weak association. This one's pretty strong. So it seems like acreage has a much better association with the value of the land than the number of rooms in a house does. Acreage, since this scatter plot has less vertical variation. If you were trying to predict the value of a parcel of land on which there is a home in this area, would you be able to make a better prediction by knowing the acreage or the number of rooms in the house? Well, of course, acreage. It has a stronger association with land value.